Hello everyone. So today's question is redundant connection, and this is day 25 of June Leetcode challenge. In this problem, a tree is an undirected graph that is connected and has no cycles. Okay, you are given a graph that started as a tree with n node labeled from 1 to n with one additional edge added. The added edge has two different vertices chosen from 1 to n and was not edge that already existed. Okay, the graph is represented as an array edges and the length of n where edges of I is ai bi indicates that there is an edge between ai to bi in the graph. Okay, so if you don't understand the question is saying that initially you are given with a tree which is an undirected graph and has no cycles, and now in between we added such a edge from 1 to n, and this edge is now causing a cycle in the graph, so we need to remove this edge and return the original initial graph. So we need to find out which edge was there which was causing this cycle in the graph. So one thing they mention in the question is that if there are multiple answer, return the answer that occur last in the input. This lines is only for confusing. This line makes no sense because there cannot be multiple answer, because multiple answer means there will be more than one edge that would be causing a cycle. So even if we remove the last edge that would causing a cycle, there will be more edges in the graph remaining that will be causing cycle, which contradicts the given statement, because given statement was initially we had a tree and there is only one edge that is causing a cycle. So there cannot be multiple edges, there cannot be multiple answers. Multiple answer will means that there are multiple edges which is causing a cycle, so there will only be one answer in every case, so we can just ignore this line. So I hope the question must be clear now. So we need to find out the first edge which is causing a cycle in the graph. This is it. So let's see how we can proceed with this question. So let's understand better on the whiteboard. So given that given edges are 1 comma 2, so first of all I will add an edge from 1 to 2. Now from 2 to 3, so I will check whether there is already a path between 2 to 3. Because if there is a path between 2 to 3 already existing, that means I would be adding another edge which is causing a cycle. No, but here there is no edge or no path already existing between 2 and 3, so we will add this edge from 2 to 3. Now so far so good. From 3 to 4, so 3 to 4 there is also no path, so we will add this edge and it will not cause a cycle. Now comes 1 comma 4. So if you see 1 comma 4, I will check whether there already existed a path between 1 and 4. So yes, there is a path existing between 1 and 4. So which path? This is the path, this is existing between 1 to 4, and since it is an undirected graph we can go in both the directions. So if I add this edge 1 comma 4, this will cause a cycle. So this is the first edge I would find which will cause me a cycle. So my answer will be this edge only, and I don't need to do anything further, because we already proved that there will be only one answer, and now we have find the first edge which is causing a cycle in the graph, so it will be our answer. So this will be the logic. So now one thing is remaining, how we will check that whether a path is existing between two edges or not, two nodes or not. So we will do DFS for that, and we will run a DFS loop. If we were able to reach from a node to another node, then there was a path between with these nodes. So let's understand with the code how we can do it, and there would be better understanding in the code. So let's move on to code. So let's start the coding part. So first of all we will need to create the graph. So I will use adjacency list method of creating the graph. So I will use a key value pair where key will be my edge, key will be my node, and the value will be a vector of integers which will be all the nodes which are connected to this key node. So I will take unordered map, and I will say its key will be node and its value will be vector of integers, so it will give me a graph. So this is our graph. For now, what we will do, we will say auto for all the edge in the edges. So now for every edge, so which basically means for every single edge, what we want to do, we want to say its starting u will be edge of 0, and its end v will be edge of 1. So now we want to check whether this edge is creating a cycle in my graph. So I will say if, so it creates cycle, so I will name the function like this. So if this creates a cycle, this means this was my answer itself. So I will simply say return this edge, nothing more to do. Otherwise I will just continue to create my graph. So else I will say graph of u dot pushback this v, and graph of v dot pushback this u. I think I am mistaken here, so it is graph. Yes. Now so this is it, like this is only what we need to do, and let's write something like return empty. Our code will not reach here in any case, because we will definitely have an edge that will create a cycle. So we will say empty vector we can return from here, and this is nf reason, so our code will never reach here. So now let's implement this. It creates a cycle function, which basically means we need to run dfs and check whether it is possible to go from edge u to edge v in the graph. So we will pass u, v, and this graph itself, and one neat thing is previous, so I will pass as 0. I will explain how I am passing 0 and why I am passing 0. So first of all, let's see this. This function will be a bool function, so it creates cycle, and I will say int u, int v, int previous, and this is my graph. So let's copy this and let's paste it here. So yeah, now I would say, so this pre will be basically our previous parent, which was of u. So it is just working like visited array we was using in the dfs. So we will say like if our u is equal to v, this means we find these both nodes were same, so we will return true from here. Otherwise for auto, all the neighbors of this vu, so all the neighbors where we can go to from this u, I will traverse. So all the neighbors and we are neighbors. So from graph of u, so if this neighbor is previous, which means if this neighbor is the parent node that from which we came, then I will continue. So if this neighbor is this neighbor is pre, then we will continue. Otherwise, if I will check it creates a cycle, so basically now we will check for all the neighbors if we can reach there. So now my neighbor v will be v, and this now pre will be u and graph. So let's, if this is the case, if it returns true, then I will return true from here. Otherwise I will return false in the end. So I think this is it. We don't need to do anything else. Let's try to run this. Okay, the compilation error, else. Okay, okay, anything other than that? No. So yeah, it worked. Let's submit the code. Yes, accepted. So this was very simple question. The language was little bit weird, but I hope you must have understood this question. So what we did, we basically finded the node, we finded the edge which was creating a cycle in my graph. So there was only one edge and this statement was redundant. So ignore this statement, please. Thank you everyone. Have a good day.